And so for the other segment of my presentation, we have the logistic regression for iris. So logistic regression is used for predicting the probability of a binary outcome. Unlike linear regression, which predicts continuous values, logistic regression models a binary dependent variable. So uh, it is used for predicting the probability of a binary outcome, which can be, not in all cases, but it can be 1 or 0. And this 1 or 0 can mean two different things. Sometimes it can be yes or no. However, it is important to note that logistic regression is not limited to having only two outcomes. And in our data set, we will see to have more than two outcomes. So considering our dataset, we have here the dataset for iris categories. We can see that we have the sepal length, sepal width, petal length, and petal width, and the species. So going back to our VS Code, um, let us start importing the dataset and see the overview of our dataset. Display its info saying that there are a total of 150 entries, and let's proceed to the next part. For the next part, we will now choose our independent and dependent variables. Since for this dataset, logistic regression has been assigned, which is why we'll need to find a output of we will need to find binary outputs or binary outputs represented by names. And in this case, since the other variables are uh, represented numerically or quantifiable, we will use the species as for our binary output represented by names. This will be our dependent variable, and our dependent variable can result into three outputs, namely the three different species of irises, setosa, versicolor, and virginica. Now that we have our independent variables and dependent variables, we can now proceed to implementing or extracting them into the code. So for our x variable, our independent variables, we will choose the sepal length, sepal width, petal length, and petal width. And for our y variable, our dependent variable, we will choose our species. So proceeding to our code again, we will now visualize the frequency of the values for each independent variable via a histogram. We can now create our training set and test sets. We have our X-train, X-test, Y-train, and the Y-test. So in order for our logistic regression to have a more efficient time in finding the natural patterns within our data, we will use a standard scaler, which from the name itself, it serves as a standard for the values within our dataset so that our model can have an easier time predicting the outcomes. So after implementing a standard scaler, we will have our X-train again and have the results from being scaled. Next one is the building and training the model. So for our model, we will have a logistic regression and a maximum iteration of 1000. So from what it says here, it simply says that there will be 1000 iterations of the model so that it can arrive to a more practiced or well-trained model for a more effective outcome. In order to evaluate the effectiveness of this model, we will now proceed to our confusion matrix to see if our model is really a good model, an effective model, via our confusion matrix. So as you can see here, there are numbers 14, 15, 13, 2, and 1. And if we total them, it will have a total number of 45 instances. This number of 45 instances is based from our tested model. So from here, we can see a test size of 0.3, which means that 30% of all the entries from our dataset, which is 150, will be the number of instances presented in our confusion matrix, which is 45. So what this confusion matrix means is that for the first row, for Iris setosa had 14 instances of being correctly predicted and 0 instances for being predicted other than its true label. So, ibig sabihin, tama po yung mga na-predict nila and nagmamatch po sila sa true label. And for the second row, which is the Iris versicolor had 15 instances of being correctly predicted and 0 instances for being incorrectly predicted as Iris setosa. However, it had 1 instance of being incorrectly predicted as Iris virginica. So, may 1 instance po siya na mali po yung prediction. Kasi na-predict po siya as Iris virginica instead of Iris versicolor. And for the third row, Iris virginica had 13 instances of being correctly predicted and 0 instances for being incorrectly predicted as Iris setosa. So, however, it had 2 instances of being incorrectly predicted as Iris versicolor. So, yun po ang ibig sabihin ng confusion matrix natin. And proceed po tayo sa accuracy ng ating model. So, this accuracy, actually ito po yung R-square and ito po yung manual computation and ito po yung sklearn. So, parehas naman po yung sagot nila, 0.9333. And ang ibig sabihin po ng 0.933 for our R-score is that this model is good. So, di po siya perfect model na suspicious, nasa good model po siya. Yung tama lang po. And proceeding with ayun lang naman po. For the discussion naman, this dataset for classifying iris categories has its advantages and disadvantages for implementing machine learning via logistic regression. So for our first advantage, this dataset has no missing values and each result has its accompanied complete data. And 2, the output for classification can only result to 3 outputs and is not complicated compared to other datasets na medyo marami-rami na. And 3, this dataset is easy to process due to its low amount of entries. Kasi kaunti lang yung entries niya, medyo magian-gian siya sa laptop and madali siya ma-process. Pero nagiging disadvantage rin yan. Kasi we should know that machine learning improves as more entries are processed and learned by the model. However, this model has very few entries, 150 compared to other datasets na nagre-range na into thousands and has a lot of room for error when implemented on real-life applications. However, after tweaking the code to the programmer's best ability, we were able to find an acceptable and accurate result suitable for the dataset provided and has been a good opportunity for learning and understanding the concepts and application for logistic regression throughout the video. And yun lang po. Thank you for listening and take care.